Hey computer, what's the time?
It's 9:59 p.m. AEST on Wednesday, 20 May 2026.
So, a few months ago, I started toying around with OpenClaw. For anyone who does not know what OpenClaw is essentially an open source AI agent that runs on your computer. It can interact with your system, run commands, solve tasks, and generally act as an assistant that can access your local environment. When I first started using it, I was absolutely amazed by what it could do. Even if it even when it could not do something directly, which happened a lot, it would often find a way around the problem. The more I used it, the more excited I became about its potential. And then I had an idea. What if I could just talk to it whenever I wanted? Instead of typing commands or prompts into OpenClaw, what if I could use it like a Google Home or Amazon Alexa? But instead of just asking basic questions like, "Hey Google, play this on Spotify," or "Alexa, turn on the lights," I could talk to an AI agent that could directly do things on my computer. Instead of The original idea seemed really simple. The assistant would listen for a wake word, start transcribing once a wake word was detected, then send the transcription to OpenClaw, and finally read OpenClaw's response back using text to speech. At first, I thought the project would be simple enough that I did not have to even create an architecture document. That was definitely an oversight, because once I started building it, I realized that there was a lot more happening underneath than I expected. The basic architecture works like this. The program is constantly listening in the background. To detect the wake word, I wanted something simpler rather than a specialized wake word detection tool. So instead, the assistant continuously records and transcribes audio in real time using a lower accuracy transcription model. This helps save compute resources while still allowing it to detect when the wake word has been said. The wake word itself can now just be a variable, so it can be changed really easily. Once the wake word is detected, the assistant switches to a higher accuracy transcription model. This this model is then used to transcribe what the user says after the wake word. That transcription is sent to OpenClaw, OpenClaw processes it, and then the response is read aloud using text to speech. For the text to speech system, I originally used 11 Labs because the voices sounded really natural and especially because it had a free tier. But after using it for a while and testing, I realized I didn't have many tokens left for the month, so I had to fall back to Groq. That's not Grok, that's Groq. They are known for really, really fast inference times. As I kept working on the project, I had another idea that made it way more unique than a regular voice assistant. One flaw with most voice assistants is that they are not very conversational. Usually, you have to say the wake word again every time you want to ask another question or give another instruction. But since OpenClaw is powered by a large language model, which means it's designed for conversation, it felt like a waste not to take advantage of that. So while setting up the foundations of the project, I added a conversational timeout system. After OpenClaw responds and the text to speech finishes, the assistant keeps listening for a short period of time. If the user says something else, it continues the conversation without needing the wake word again. But if the user does nothing, it times out and returns to waiting for the wake word. This makes the assistant feel a lot more natural to use because you can have back and forth conversation instead of constantly restarting with the wake word. One of the biggest problems I had while building this project was getting OpenClaw to connect properly. When I started working on it, I had OpenClaw running on a Proxmox virtual machine on my framework laptop. The long-term idea was that OpenClaw could always be running on the virtual machine, while the actual voice assistant could run on something similar, like a Raspberry Pi. That way, the assistant would not be independent on my MacBook unless it specifically needed to run commands on it. However, that turned out to be surprisingly difficult. The hardest part was trying to get the agent to run commands on my MacBook when I needed it to, but also run commands on the Proximox virtual machine when it could not run them locally. There were a lot of issues around networking command execution and deciding which machine to handle which tasks. Because OpenCore has a really, really vast security system because of all the incidents that have happened in the past. So you pretty much have to blacklist or allow list different commands or operations OpenCore can do, which is really annoying. This was one of the areas where I used AI most. I used it to help through I use it to think through the connection logic, generate parts of the OpenClaw client, and debug the problems I was having with the different machines talking to each other. Eventually, I simplified the setup and got it working directly on my MacBook. That avoided a lot of the issues with the virtual machine setup and made the project much easier to test, even though the Proxmox and Raspberry Pi setup was the original goal. Getting it to work locally first was a much better step for the project and helped with the MVP. I used AI in a few main ways throughout this project. First, I use it for brainstorming. It helped me think through the architecture and decide how different parts of the assistant should connect together. Second, I use it to generate the OpenCore client, especially when I was working out how to send prompts to OpenCore and receive responses properly. Third, I also used AI to clean up my final code. As a project grew, there were parts of the script that became really messy and difficult to follow, so I used a lot of AI to refactor and organize it. I also used AI for a lot of debugging, especially when dealing with connection issues or little audio tweaks, and especially using async. Overall, the project is a conversational voice interface for OpenCore. It listens for a wake word, transcribes what the user says, sends that transcription to the client, to the agent, reads a response back with text to speech, and then allows the conversation to continue naturally without needing it to repeat the wake word every time. The main thing I learned from this project is that even when ideas seem simple at first, they can be so much more complex when you start building on them. On the surface, this was just a voice assistant, but underneath that, there were problems involving the transcription, wake word detection, text to speech, API connections, timeouts, local command execution, and system architecture. Alright, so now I'm going to give you guys a working demo of this project. So, the advantages of this is that I should just be able to say whatever I want, and then it shouldn't listen to that. And then if once I say the wake word, which in this case is computer, it will transcribe that. It will transcribe what I say afterwards, um, and send that to OpenCore and read it back. And we'll also test out the conversational mode. Yeah, let's get started. So just as a test, it shouldn't detect any of these things as the wake word. Yeah, perfect. Hey computer, what's the time?
It's 9:59 p.m. AEST on Wednesday, 20 May 2026.
Thanks.
No worries.
Can you press play on Spotify?
Done. I told Spotify to play.
Can you pause Spotify? Well, it clearly works. Just need to figure out some little kinks in the actual it actually started transcribing the song. That's quite funny. I didn't take that into account. But yeah, it works. For the thinking noise, those little bom bom bom. It that was straight from ChatGPT. I went into ChatGPT voice mode, gave it a query, recorded it, and just cut out that and use that because it needs to have that feedback when you say it. Because if you have it on a device like a Raspberry Pi, where you don't have a screen, if you just say something, you don't know if that request has been taken in until OpenCore actually responds later, and that's just not a great human interaction. So here it's a lot more natural. One disadvantage at the moment is that seeing that this is an agent that wasn't made to be fully conversational, it can take a while on certain requests. As you can see in that Spotify demo, it pressed play and then later said that it had done it. That's just it going through the commands individually and messaging, which is it just going through the pipeline. So to improve this, I suppose you could have a tweaked OpenCore settings where it can work a lot quicker, doesn't take as much time to think, maybe runs on minimal tools, and maybe uses a better language model provider like Groq, Groq, same one as before, um, for better, um, for quicker language model requests. So yeah, thank you for your time and watching this video, and yeah.